Hi friends, in the video we will talk about the laws of thermodynamics. So, thermodynamics is a branch of physics which deals with the study of transformation of heat into a mechanical work. அதாவது ஹீட் எனர்ஜி வந்து மெக்கானிக்கல் ஒர்க்காக கன்வெர்ட் ஆகிறத பற்றி படிக்கிறது தெர்மோடைனமிக்ஸ். ஸோ இங்கே தெர்மோடைனமிக் சிஸ்டம் பற்றி ஃபஸ்ட்டு தெரிஞ்சுக்கலாம். தெர்மோடைனமிக் சிஸ்டம் வந்து என்னென்னா ஒரு டெஃபினிட் குவான்டிட்டி ஆஃப் மேட்டர் வந்து பவுண்டட் பை க்ளோஸ் சர்ஃபேஸ். ஃபார் எக்ஸாம்பிள் ஒரு கேஸ் மாலிக்யூல்ஸ் வந்து இட் இஸ் க்ளோஸ் இன்சைட் எ கண்டெய்னர் வித் அ மூவபிள் பிஸ்டன். ஸோ இது வந்து இட்ஸ் செட் அஸ் தி க்ளோஸ்டு சர்ஃபேஸ் தட் இஸ் தெர்மோடைனமிக் சிஸ்டம். So இங்கே வந்து not only the gas molecules, the system may contain only the solid particles, the system may contain only the liquid particles. So this can be said as the thermodynamic system. So it is of two types, one on the homogeneous system and the second one the heterogeneous system. Homogeneous system na and the system fullaவே it contains only the same type of matter. For example, gas molecules inside a cylinder, only gas molecules, which is the material which is the cylinder which is filled with only the solid particles, it is filled with only the liquid materials. Now we can tell this is of homogeneous system. And next is heterogeneous system. Now it consists of two or more phases, அதாவது ரெண்டு மேட்டர்ஸ் கம்பைன் ஆகி இருக்கிறது heterogeneous system. For example, liquid with a gas molecule, solid with a liquids, this can be said as immiscible liquid or immiscible liquid. அதெல்லாம் வந்து heterogeneous system. And the surrounding, it is nothing but which can exchange the energy with the system, that is said as the surrounding, and a system through which heat or mechanical energy pass through its thermodynamic system. Thermodynamic system now which transfers the heat or mechanical energy, and the surrounding என்றது வந்து anything outside the system which can exchange energy with this. So this is said as the surrounding. And next is thermodynamic variables and equation state. பார்த்தீங்கன்னா 4 observable properties இருக்குது: composition, pressure, volume and temperature. An equation of state for ideal gases given by the equation pressure into volume is directly proportional to the temperature. அதாவது as the temperature increases, the product of the pressure and volume also increases. Temperature decrease ஆகும்போது pressure and volume also decreases. And the proportionality remove பண்ணுறதுக்கு we are introducing a constant R. This constant R is said as the gas constant. And next is for van der Waals gas molecules இருந்ததுன்னா, and the equation is given as P plus A by V square அப்புறம் V minus B equal to RT. So இங்கே A and B என்றது it is arbitrary constants. And next discuss about the classes of system. So இங்கே there are 3 types of classes of system: open system, closed system and isolated system. Here coming to the open system, so இங்கே இந்த சிஸ்டம் வந்து which can exchange matter and energy with the surrounding. அதாவது ஒரு மேட்டர் எனர்ஜி எக்ஸ்சேஞ்ச் வித் சரௌண்டிங் அந்த ஓப்பன் சிஸ்டம். எக்ஸாம்பிள் வந்து ஏர் கம்ப்ரெஷர். ஸோ ஏர் அட் லோ ப்ரெஷர் என்டர்ஸ் அண்ட் ஏர் அட் ஹை ப்ரெஷர் லீவ்ஸ் த சிஸ்டம். ஸோ இங்கே எக்ஸ்சேஞ்ச் ஆஃப் மேட்டர் அண்ட் எனர்ஜி டேக்ஸ் பிளேஸ் வித் த சரௌண்டிங். ஸோ இது சிஸ்டம் வந்து இட் இஸ் டேர்ம்ட் அஸ் ஓப்பன் சிஸ்டம். அண்ட் க்ளோஸ் சிஸ்டமாக இருந்ததுன்னா which can exchange only the energy with the surrounding and there is no exchange of matter. This is closed system. இதுக்கு எக்ஸாம்பிள் வந்து gas enclosed in a cylinder which expands when heated and drives a piston outwards. So இங்கே boundary of the system moves but the matter in the system remains constant. boundary மட்டும்தான் மூவ் ஆகுது, மேட்டர் வந்து it remains a constant. And here the exchange of energy takes place. For example, நம்ம LPG cylinder பார்த்தீங்கனாலே, so when we uses this, here we are getting the heat energy and there is no loss of any matter. The energy, the work done is in the form of exchange of heat energy. So this is closed system. Isolated system na a system which is thermally insulated. So completely the system is surrounded by insulating material, and when it is surrounded by insulating material there is no loss of energy and there is no transfer of matter with the surrounding. This is isolated system. And next is laws of thermodynamics. பார்த்தீங்கன்னா first law is zeroth law. So இந்த zeroth law படி என்னன்னா, if two bodies A and B are in each separately in thermal equilibrium with the third body C, then here we can tell A and B are also in thermal equilibrium with each other. அதாவது மூணு மெட்டீரியல்ஸ் எடுத்துருக்கீங்க A, C and B, but ஏவும் பியும் it is not in direct contact but it is in direct contact with the C. So C மூலியமா we can tell A and B is also thermally equilibrium because C it is connecting A and B. C here under the condition A, C, B are perfectly conducting materials. So this is said as zeroth law, and next is first law of thermodynamics. First law of thermodynamics nothing but the amount of heat energy which is equal to the increase in the internal energy plus the work done. அதாவது when a certain amount of heat is supplied to a system which does some external work W in passing from state 1 to state 2. அதாவது ஒரு ஹீட் எனர்ஜி சிஸ்டம்க்கு சப்ளை பண்ணும்போது இங்கே வந்து ஒர்க்கு நடக்குது. அந்த ஒர்க்குனால என்ன ஆகுதுன்னா அந்த சிஸ்டம் வந்து இட் மூவ்ஸ் ஃப்ரம் த ஸ்டேட் ஒன்லேருந்து இட் இஸ் மூவிங் டு த ஸ்டேட் 2. ஸோ இங்கே அமௌண்ட் ஆஃப் ஹீட்ன்றது it is equated to the increase in the internal energy of the system and the external work, and this can be given by the equation Q is equal to U2 minus U1 plus W. So inge when coming to the point internal energy na enna, the energy content of a system is internal energy, and this internal energy is given by the summing up of three energies. One is kinetic energy. The kinetic energy எதனால நடக்குதுன்னா due to the translational, rotational and vibration motion of the particles. Second is potential energy. This is due to the intermolecular forces, and this which depends on the separation between the molecules. And third is energy of the electrons and nuclei of the atom. So because of these three energies we get the internal energy. And so in the first law of thermodynamics, again I'll repeat this. When a certain amount of heat is applied to the system, work done. So some work is done, that is denoted as W, which moves the system from state 1 to the state 2. This is first law of thermodynamics. And next we'll discuss about the thermodynamic processes. First is adiabatic process. In adiabatic process na enna na, inge there is no energy transfers, heat energy transfers. No heat leaves or enters the system. So இது வந்து adiabatic process. So no heat energy leaves or enter the system na. So in the previous on a first law of thermodynamics equation body Q வந்து it is taken as 0, and now the equation is changed as W is equal to minus CV and DT, that is C at constant volume and D at the constant temperature. And இங்கே வந்து system expands adiabatically, internal energy decreases. Adiabatically expand ஆச்சுன்னா the internal energy will be decreases, and system compressed adiabatically means then W is negative. இங்கே C என்றது என்னன்னா specific heat capacity, it is denoted as C, and here the small change in the temperature it is given as dT. And next is isothermal process. So system it is perfectly conducting and the temperature remains constant. System வந்து perfectly conduct ஆகுது, இங்கே temperature is remains constant. So அந்த equation ல Q is equal to W, and here U2 minus U1 becomes 0, and the graph which represents a graph between P with the V. Here for the isothermal process we get the graph like this, that is here the temperature T remains a constant, and the matter it moves from the state A to state B. And next is cyclic process. So in the process படி பார்த்தா the system is restored to the initial state at the end of the cycle. So A லேருந்து start ஆகி it is going to B, again from B it is coming to the same point A. So இங்கே energy equation is given as by measuring the area of the curve. Here the area of the curve it is taken as ACBDA. So this is cyclic process. அதே ஆரம்பிச்ச இடத்துலயே வந்து நிற்கிறது வந்து it is cyclic process. And isochoric process, so here volume remains constant. Isochoric ஞாபகம் வச்சுக்கோங்க, volume remains constant. At constant volume ல no work is done. So இங்கே isochoric process ல the main important point is volume remains constant, so that there is no work done. And next work done it is can be taken as 0. Next is isobaric process. Inge pressure is kept constant. So here the energy equation is given as Q is equal to U2 minus U1 plus V. So Q is equal to U2 minus U1 plus work done it is given by the equation P into V2 minus V1. So by simplifying this, we get U2 plus PV2 minus U1 plus PV1. So Q is equal to H2 minus H1. So U2 plus PV2 we are taking as a single constant H2. So in the energy difference, H2 minus H1 is nothing but taken as a single constant H, which is equal to already we know in energy Q and it is given by the equation the internal energy U plus the work done. Here the work done is given by the equation pressure into the volume. So H is nothing but enthalpy, change of internal energy. This enthalpy. Thank you for watching.